What is this? From the figure you can understand there is a two zone, oxic and oxic. Oxic means aerobic and oxic means anaerobic. It is clarified, Wessler, again it is written. So it is somewhat combination of modified Ludwig process and here, because here by changing the location of aerator in between mixture, the oxidation disk can be operated like a Baden-Fork process. So these two processes we already discussed. Let us see what are these two processes, then it is going to be more clear. कहाँ पे चला गया? You just see, he is talking about this process and this process. An oxic zone aeration tank means oxygen, and here recycling is there, and it is a combination of this oxic and oxys, again replace the position. So here they are replacing the position, that's why it is written. This oxidation, this can perform biological nutrient nitrogen removal by creating two zone in parts of there. This configuration is like Werman process by changing the location of aerator and mixture, the oxidation disk can be operated. So that's why the good thing is here, this oxidation disk can create recycle rates without the need of pumping to the return. But what will be the disadvantage? Can anybody tell? It is a combination of many processes. What are the disadvantages?
Maintaining the
large surface area, sir.
Large surface area. और treatment plant की हमारी सबसे बड़ी problem है. Lagoons are good, but this implementation of this lagoon is a challenging task. We know that we did not have this much land. So this is oxidation disk. So we already discussed number of the method where we understand the what is the process of nitrogen removal using nitrification and denitrification. What are the process control variable? What are their limitation? And these things is discussed in table 8.23. Please go through by yourself. And these are the typical design parameter. Okay? So these are the methods. We already discussed number of methods. Here SRT time is there, MLSS concentration is there, anoxic zone, aerobic zone, return activated sludge, percentage of influent, internal recycling of influent. These are things that are given. Please go through here. Nothing is discussed. These are the range which is required when we are trying to design the reactor system for biological nitrogen removal. So all these things with respect to biological nitrogen removal. Now let us talk about the removal of nitrogen by physical and chemical process. So physical and chemical process, once the term came, physical and chemical process mean somewhat we can say that now money is going to be matter. Why money is going to matter? In physical chemical process, sometimes required some broad structure, and sometimes we need chemical. And chemical is one of the complicated things. It's required a huge investment. Okay? And that's why it is a quite costly process, and most of the time it is not preferable. But in some specific condition where the operational condition favor to do the physical chemical process, then in that case we can do it. Like ammonia removal using air stripping process. So we know that this process can be done only and only when we are able to raise the pH. And suppose in industry we have an option where waste is something like that, where by which we can raise the pH. In that case it is okay. Otherwise it is one of the costly method. So let us discuss about the physical chemical method. This physical and chemical process, which is used for nitrogen removal are air stripping. Air stripping means conversion of this thing, nitrogen to equilibrium phase, breakpoint chlorination for oxidation, and selective ion exchange. All these methods are popular, but have some limitation. Let us discuss one by one. So I already discussed this. Still, researcher, field engineer, they prefer to use biological treatment system for the nitrogen removal rather than the physical and chemical process. Why? Because first thing is, whenever we are talking about treatment process, our first thing is the cost. And in physical chemical method are too costly. Second is inconsistent performance. Why inconsistent performance is there? Because we know that if it is a physical chemical process, means process control variable is going to play very important role. And if the dose operational condition is going to change, then what will happen? It is going to a drastic reduction in the removal efficiency. And that's why, and another important parameter. So another important parameter is maintenance cost, because when you are going to use chemical and other things, it is sometimes it may be corrosive, it is going to damage the reactor system or the feeding equipment. That's why it is not so popular like a biological treatment system, especially in the physical nitrogen removal. So let us discuss first process, air stripping process. Under properly controlled conditions. What is mean properly controlled condition means if everything is well within optimized condition. Air stripping can remove ammonia nitrogen from wastewater, ammonical nitrogen, ammonia nitrogen, by converting it to ammonia, okay, which exists predominantly in the unionized gas from at a high pH level. So we are able to convert this ammonia into unionized gas. So what is the meaning of this thing? This gaseous phase NH3 and aqueous phase ammonium exist together in equilibrium and controlled by pH and temperature. So we know that whenever the distribution of NH3 and NH4 in water, especially means in wastewater, it is depend upon the pH. Their composition, which one is going to be higher and which is going to be lower, is depend upon the pH. So if higher pH is there, so what will happen? This ammonium is going to convert into NH3 phase. So this dissolved ammonia is converted into gaseous phase and dispersed in the air, thus allowing transfer the ammonia from wastewater to the air. The pH must be 11 to complete conversion to NH3. From the previous slide, now you can understand sufficient hydroxide required, and we can get sufficient hydroxide only when sufficient means a higher pH side. At higher pH side only we are going to get sufficient hydroxide. Typically, lime is the most common means for raising the pH. pH कैसे लिखा है? Enough time must be added to precipitate the alkalinity and to add the excess OH ion for pH adjustment. So, but naturally, we already discussed that it is highly dependent upon the pH. Next thing is air to wastewater ratio. Why air to wastewater ratio is there? If sufficient air is not there, then what will happen? Oxygen is not going to be there. And so what will happen? It is not going to elaborate during this thing. So this conversion process requires a sufficient air. If sufficient air is not there, then what will happen? You are not able to convert this thing. Next is depth. Why depth? Because depth is somewhat is important. It is contact time, because its depth is going to define the contact time between the wastewater and media. So that's why it is one of the important, because some time is required to complete the reaction. It does not work very efficiently in cold weather, but this process is simple but has serious drawback at that it makes expensive. Why it expensive? Because a lot of lime is required. Because of the high operating maintenance costs associated with air stripping, the practical application is still limited. In most cases where air stripping has been applied, a number of problems has been developed, such as calcium carbonate scaling within the tower, because tower have a media. Tower has a media, and where calcium carbonate scaling is going to end. Feed lines for poor performance during cold weather. High pH range result in the absorption of CO2 from air. This is very important. Higher pH range, this thing, and development of the carbonate scaling. As the temperature decreases, the amount of air required increases significantly for the same degree of removal. And if you need excess air, in that case, you require a more depth. And that again, it is one of the problematic things when we are talking about this thing. With icing occurs, the liquid air contact geometry in the tower is altered and the overall efficiency is further reduced. That's why it is not popular. So another problem, what we told that we discuss only one process. Air stripping, we already discussed. What are the advantage and disadvantage? Let us again one time we are going to discuss. Air stripping, this process can be controlled for selected ammonia removal. How? Why? Because you are able to control pH, you are able to control the contact time, you are able to control the depth of the tower, you are able to control the flow rate. Most applicable is required seasonally in combination with lime system for phosphorus removal. And same time, a combined system can be used for ammonia as well as phosphorus removal. Process may able to meet total nitrogen standard. But the good thing is that here, other than this advantage, one good thing is that there is no byproduct. That is very important. There is no byproduct. There is no fouling. There is no fouling. And that's why some researchers feel that it is better than the breakpoint chlorination. So you people have already idea about what is breakpoint chlorination. What are the disadvantages? Process is temperature sensitive, because that's why in cold country it is not favorable. Ammonia solubility increases with lower temperature. Air requirement also vary, fogging and incident occur in cold weather. These are the already we discussed. Ammonia reaction with sulfur dioxide may cause air pollution problem. So that's why air stripping, air is going to release, and if sulfur content is there, then sulfur oxide is going to form. Process usually require lime for pH control, thereby increasing the treatment costs. So these are the problem. Scaling and other things we already discussed this thing. Now next is breakpoint chlorination. So chlorine is well known for their high oxidation efficiency. So if proper control is there, all ammonia, nitrogen can be oxidized. That's why this is the good thing in chlorination. Very high efficiency. But there is one major problem with the breakpoint chlorination. It is going to create a number of carcinogenic products. And that is one of the disadvantages. Process can be used following other nitrogen removal process. Sometime what we are doing, we are trying to remove the nitrogen using biological system. But biological system suppose not able to remove 100% and 2%, 3%, 5% remove. In that case, we are going to do breakpoint chlorination. In that case, even though there will be byproduct, but their concentration is going to be less. Process can be used following other nitrogen removal process for fine tuning of nitrogen removal. Concurrent effluent disinfection, limited space, and same time it is going to do disinfection also along with nitrogen removal. Limited space is required because in a very small size reactor is required because contact time is very less. Space is totally dependent upon the contact time, and in chlorination oxidation is one of the fastest oxidation method for any pollutant removal. Not sensitive to toxic, not temperature means is not going to affect. Low capital cost, only chlorine is going to be cost, and that bleaching powder is quite cheap. Adapter of existing facility, and the good thing that you can add this system to any existing treatment system. That is the advantage. Next, may produce high chlorine residue. Because breakpoint chlorination, it is wastewater. Because it is wastewater, so ammonia chlorine demand is going to be high. Once chlorine demand is going to be high, but natural more chlorine residual is going to be there. That are toxic to aquatic organisms. Wastewater contain variety of chlorine demanding substance which increase the cost of the treatment, but natural. If too much chlorine demand is there, then chlorine dose is going to increase, and which finally going to cause a higher dose. Process is sensitive to pH, which affect dosage requirement, but natural. We know that. किसी को याद है ये? वाटर सप्लाई में हमने पढ़ाया था.
pH.
No. याद करिए.
So breakpoint chlorination was the chlorine dose with which we can treat all the whatever the impurities are in there.
I'm talking about this figure.
So which one? Okay.
This is HOCl, this is OCl, and this is pH dependent. Now you know. It is memorized or not?
Yes, sir. It was.
That's why process is sensitive to pH.
Yes, sir.
Because we know that HOCl is more
HOCl remains for,
so
yes, sir.
that's why it is a process is sensitive to pH, which affect dosage requirement. High operating cost due to chemical requirement. Trihalomethanes. What is trihalomethanes? Tell me, what is trihalomethanes? बताइए. What is trihalomethanes?
CHCl3 सर.
क्या होता है, कहाँ पे आता है, वो तो फार्मूला कोई बता सकते हो आप, वो आता कहाँ से? दिस इज नथिंग, इट इज ए बाई प्रोडक्ट, जो मैं बार बार बोल रहा हूँ. दिस इज डिसइंफेक्शन बाई प्रोडक्ट. जब आप किसी वाटर में क्लोरीन डालते हो, दैट वाटर वेस्ट वाटर हैव अ लॉट ऑफ ऑर्गेनिक मैटर, and that organic matter is reacted when it is going to react with the chlorine. A number of byproduct is going to form, and out of that number of byproduct, trialomethane is one of the most common byproduct. We can say that 90% contribution of the byproducts is because of the trialomethane. That's why it is one of the most popular byproduct when I'm talking about chlorination. Addition of chlorine raise effluent TDS. Why it is going to increase the effluent TDS? Why addition of chlorine raise effluent TDS? You people are suspended impurities रहेगा, that is going to oxidize. In oxidize, after oxidation, in product is going to form. In product may be dissolved substances. That's why TDS is going to raise. थोड़ा थोड़ा बताने की कोशिश किया करो. Sometime everything is not written in book. but it is well understandable. Process may not able to meet total nitrogen standard. Maybe sometime it is not going, sometime it is required or not required. Required careful control of pH. Okay? So these are the skills operation condition is required. So these are the common requirement. Ion exchange. What is the biggest problem in ion exchange? Can anybody tell what is the biggest problem in ion exchange? Tell me.
Regeneration of resins.
One, people are doing lot of research on that thing. बताइए. बताने की कोशिश करिए.
कॉस्ट सर इसका ज्यादा है.
अच्छा,
सर वेस्टेज
प्रॉब्लम मैं पूछ रहा हूं. एनी पीएचडी स्टूडेंट?
कैल्शियम सल्फेट का फॉर्मेशन होता है सर. सर वेस्टेज
This is the biggest problem. So resin, if it is inorganic components, because ion exchange is made, ion exchange process is most you can say that mostly used are their efficiency is going to be maximum when it is going to use for the inorganic pollutant removal. And if suppose I want to remove cadmium from the water, so we can design a resin where it is cadmium is going to exchange and it can be easily removed. A very cost effective and very good thing is there. But what the thing is going to create the problem. Along with that cadmium, water is going to have number of other components, and organic carbon may be there. Those organic things, okay, is going to bind with the resin of the ion exchange, and falling is going to occur, and that overall efficiency is going to reduce. That is the biggest problem in resins. Let us discuss one by one. Number one, ion exchange can be used where climatic condition inhibit biological nitrification, where stringent effluent standard are required. Means you are very focused about this thing. You want to remove 100% removal. Just wait. Okay, so stinging means you want to remove 99.99%. In that case, nothing is going to work other than ion exchange. Produce a relatively low TDS because here exchange is there, no oxidation is there, so but natural low TDS will be there. Produce a reclaimable product, aqueous ammonia. Process may be able to meet nitrogen, and that's why it's quite good thing is there. But the problem is quite more complicated compared to whatever advantage we are going to use when we are going to use ion exchange. What are these? Organic matter in effluent from biological treatment can cause resin binding. Pre-treatment for filtration is usually required to prevent buildup of excessive head loss due to suspended solid accumulation. What happens if suspended solid is there? So they are going to accumulate on the surface of the resin and they are going to block the surface. And because of that, exchange of the ion is going to reduce or it is going to be altered. High concentration of other cations will reduce ammonia removal. If same nature of other ion is there, so but natural, we don't want to remove other than ammonia, but the thing is that their physical condition and as well as the chemical condition are same like ammonia. So what will happen? Along with that, ammonia is also going to remove. Regeneration recovery may require addition of another unit because that's why it is always required. And it is a cost input is quite high capital operating cost. Regeneration product must be disposed. And the thing is that आपने cadmium का भी मैंने example दिया, cadmium का आपने regeneration कर दिया. Now the problem is that we need to, हमने cadmium का कर लिया. Now we need to, during regeneration, the cadmium exchange in this resin need to dispose. A very careful attention is required. So this is an exchange process. Now another popular method, that is NMOX process. Anybody have idea about NMOX process? वेस्ट वाटर आप लोगों ने पढ़ा है ना? Anybody have any idea about NMOX? Okay.
Sir, we add the bacteria, sir, something bacteria which reacts with the wastewater to produce the nitrogen to release the N2, sir.
Yeah, please tell me.
So it reacts, means the bacteria consumes consumes this matter, organic matter, and they release the N2, sir, with the reactions. Something like that, sir.
Here two things is very good. Number one is nitrite to directly nitrogen gas. Means nitrite to nitrated, one step is you can say that omitted. And the good thing is that, another good thing is that, what is good thing? One thing is this. Here, denitrification is not going to occur. Without denitrification, we are able to convert nitrite to nitrogen gas, and because of that, external source of carbon is not required. But all this NMOX process is still in laboratory scale only. Still it is in laboratory scale. Till now, their field implementation is not available. We can say that no industry has adopted or no government agencies has incorporated this thing. So that's why people have number of observations, because a lot of people did research on this thing, but I don't know what is the basic problem of this thing. Still it is not implemented in field scale. So what is NMOX? Why this name is came NMOX? It is anaerobic ammonium oxidation. Okay, discovered in the early 90s. Okay, in here what happened? Bacterial transformation of ammonia and nitrate directly nitrogen gas and water instead of passing through two stages. So instead of two stages, in single stage we are able to convert this thing, and this is the reaction. Let us discuss more. What are the advantages? Oxygen addition can be reduced, resulting in energy and cost saving. So limited requirement is there, oxygen. So oxygen addition can be reduced, resulting. So once we are able to provide sufficient oxygen, so overall the cost is going to reduce. And the important thing is that NMOX bacteria do not require organic carbon, as they only do nitrification. So production of excess sludge is reduced, reduces CO2 emission, but natural, if nothing is there, so but natural CO2 is going to be less this thing. Disadvantage, sufficient knowledge is not available. Still made, meaning of this line is still their detailed design or detailed configuration is not available. Skilled operation and maintenance required. High construction cost is required is enormous process is replace the conventional nitrification denitrification the treatment plant. अब किसी treatment plant में already nitrification denitrification process है and you want to replace that process with NMOX. So generally people favor the treatment system which can be implemented in existing treatment plant rather than new treatment plant. Because why researchers focus about this thing? Because they know that even though if it is not going to work, so what will happen? We can again go back to our old system, and that's why researchers always try to develop a system which can be easily implemented in existing treatment system, and that's why NMOX is not popular so much. Stop it. So I think it is sufficient for today class. Now we will discuss about this time quiz 2. So quiz 1 में मैंने कहाँ तक पूछा था? quiz 1 में मैंने कहाँ तक पूछा था?
Sir,
First 4 slide.
First 4 slide, sir.
First 4 slide.
Yes, sir.
हाँ सर, मतलब सर नाइट्रोजन से आप स्टार्ट किए थे, फिर क्विज 1 के बाद उसके पहले सर उतना तक पूछे थे सर.
Let me check. मुझे कुछ नहीं याद आ रहा. Let me check. One, two, three, 4. हमने ऑलरेडी AWT 01, 02, 03, 04 हमने पूछ रखा है ना?
Yes sir.
Yes sir.
So this time I am going to ask from this notes. So I think इसको हम नोट्स का नाम डाल देते हैं AWWT_05. So now up to which slide we can ask? I think we can decide this thing after. Just wait 1 minute. So after Wednesday class, we will fix the means syllabus. I think in quiz 2 we are going to ask maybe up to 80 slide or 90 slide. Okay.
Yes, sir.
Please write down your attendance.
Sir, quiz, please, can you not keep on Saturday and Sunday, sir? Actually, UPSC exams are clashing.
UPSC exam timing?
It will be full day, sir. 2 paper shift, 10 to 12.
Two paper, I know full day, but no, in whole country, it cannot be from after 7 p.m.
Yes, sir. 10 to.
That I know. No,
after
none
7.
of the exam is going to held by, it is after 7 p.m. So that's why I kept the exam 7 to 7:30, so that nobody can claim that I have class, exam or anything.
Sir, but centers are little outside, sir.
So you have a mobile, na?
But
Try
video
to
we have-
understand.
Sir,
I cannot solve the problem, individual problem, because if even I am going to fix to Wednesday, then some people is going to tell I have some problem. That's why I given Friday. So it's a final. Again, tomorrow class, again we will discuss. If any solution is there, then again I am going to discuss. Don't worry about that thing. But the quiz two will be before Sunday. Okay. Please write down your attendance.